Hello. We're going to talk today about database modeling. Now, a lot of people say working with databases is very easy. It's very easy to do write queries, very easy to build database tables. But the truth is that database modeling is actually hard. When you model a database, you have to understand the information really well. You have to understand the business rules really well. I've seen many databases that were designed that seem to work in principle, but in actuality they failed once they were implemented. We're going to have to discuss how to unequivocally understand the data requirements of the business. And we're going to use some modeling languages to do so. First, we have to understand the rules of the modeling language, because the modeling language, it's called an ER diagram or an EER diagram. These rules are universal. And when you can talk to your business partner, understand the data they want to keep track of, you first need to model it in an ER diagram. I've been doing databases over 30 years. To this day, I never take on a new database project without first building a data model, without first building an ER diagram. So we're going to talk about what that means in this lesson and the future lessons around database modeling. And I hope you learn this well, because this will be a skill that will serve you very, very well in the future. So what is an ER diagram? We can turn to Wikipedia. It has a great definition of it. And they talk about an entity relationship model, or ER model. And this describes interrelated things of interest in a specific domain of knowledge. So for example, below we see some information, maybe the beginnings of an ER diagram about art. And we want to capture information about painters, and we want to capture information about paintings. And we also want to know how painters are related to paintings. Wikipedia goes on to say that an ER model is composed of entity types. Entity types. And an entity type would be these rectangles right here. These are entity types. We have two in this diagram. Entity types classify the things of interest. So in this case, we want to learn a lot more about the painters, and we want to learn a lot more about paintings that they have painted. But the ER model also specifies relationships that can exist between these entity types, and the relationships are diamonds. And so the relationship between a painter and a painting is that a painter paints a painting. Oftentimes, we will see entity types referred to as nouns. And we will see relationships often as verbs. One last thing, the difference between an entity and an entity type. So we're going to say that the entity type is painter, but an entity is a specific instance of that type. So Leonardo da Vinci would be an entity. Similarly, painting would be an entity type, but the Mona Lisa would be an example of an entity. Models can be created at various steps of the software development lifecycle process. In the beginning, you are interested in trying to understand the information elements, and we call this a conceptual data model. The conceptual data model is done typically during the analysis phase of a project, where you really want to understand the data and how it relates to one another. Then, at the very end of the spectrum, once we implement a database, we have something called a physical data model. The physical data model is what is used when we are actually creating the physical database. As you might expect, there are differences between the physical data model and the conceptual data model. The biggest difference is the physical data model is real. That's exactly what you find in your database. The conceptual data model is not meant to represent physical storage, but rather information concepts. And as you will learn in this course, we will take conceptual models and we will convert them into physical models. The conceptual models are very useful in this particular stage, in the requirements gathering stage of a software methodology. Once we move on and we begin to code, there's this intermediate step called a logical data model. Sometimes those logical data models are created, sometimes they're not created. Unlike the conceptual model and the physical model, the logical model does not have really strict rules about how it should be created, whereas conceptual and physical are very, very well defined and very specifically defined. Think of the logical data model as an intermediate step on your way to building a physical data model. And as you can see in the diagram here, the logical data models kind of bridge the phases. They bridge the functional analysis with the actual design phase. And then finally, after you've gone through these phases, you want to actually build a database, and that's the physical design. You'll see in the next slide some examples of these different models. For the most part, we are going to focus on the conceptual data model for the rest of these talks. Here we have another example of information to model. And this time we're going to talk about books and book club members. And so again, we have entity types here for a book club member, and we have an entity type for book. And at the conceptual model level, we want to keep track of some of the fields. So for book club members, we're going to want to know their email, their first name, and their last name. For books, we care about their ISBN number, the title, and the author. And here's the relationship. A book club member reads a book. You'll notice that this looks different from the ER diagrams I showed you previously. I'll explain that in the next slide. But this right here is a very good conceptual model. When I get down to the physical model, you're going to see that it's different. In the physical model, the actual database, we have the book club member table. That makes sense. And then we have the book table. But we also have a third table called books read. And this gives an example of how the physical model, how data is really stored, could differ from the conceptual model. And then finally, we have something in the middle. We have the logical model. And again, logical models don't have strict rules. A logical model essentially just has more detail than the conceptual model. And here we can see that the email is going to be a character of length 30, the last name varchar or character of length 40. Here we're going to see that the ISBN number is an int with 13 digits. So we're getting a little more detail. When we come down to the physical models below, you can see that we have the actual data types locked in here as well. We may learn other things at the physical model, such as which of these fields are allowed to be null and which are not. But when we're doing conceptual data modeling, we want to stay at the very highest level. As you may have noticed from the previous two slides, we've shown ER diagrams with two kinds of models. One has been called the crow's feet model, and one is called the Chen model. Now, the crow's feet model uses these three lines here that looks like a crow's foot, and that three lines indicates many. So this says a painter can paint many paintings. The other side of the crow's foot model has a 1, and that means that a painting can be painted by only one painter. So crow's feet model are used very frequently, but I prefer the Chen model. Peter Chen developed this in 1976, and this model is more precise. The Chen model does use the relationship construct, the diamonds, and we still have what's called the cardinality. A painter can paint many paintings, if I read from left to right, and a painting is painted by one painter, if I read from right to left. The Chen model is more precise, and so we will be using that throughout the rest of the course, but it's important for you to see a crow's foot model. One last word about the crow's foot model. You actually see two sets of lines here. The lines closest to the entity type is the maximum. So this says that a painting can have a maximum of multiple per painter. Over here, this line, which is closest to the painter, says 1. How do I read that? A painter can paint a maximum of many paintings, and a painting can be painted by a maximum of one painter. So no collaborative paintings. The set of lines that are farthest away from the entity type indicate the minimum. So we'll read this way. The painter can paint a minimum of one painting. That means every painter in our database has to have at least one painting. And a painting can be painted by a minimum of one painter. Because we have a 1 and a 1 here, sometimes we read that as one and only one. So a painting is painted by one and only one painter. Or a painter can paint between one and many paintings. If in fact we want to store information about painters that have never painted anything, we would draw it this way. We would have the 0 symbol for none, and followed by the crow's foot. And this symbol right here would replace what we have here. And if that symbol was there, I would read this as a painter can paint a minimum of 0, but a maximum of many paintings.